See that from here it will be very, very important. So as we know, till now we studied two types of hydrocarbons. Basically, all the things whatever we studied, we are having many kinds of organic compounds. The most important organic compounds are
Sir,
hydrocarbon. Yes, yes, Hare Krishna. Can you hear me?
sir, I can't hear you.
Am I audible, everybody?
Yes, sir.
Yeah,
Yes, sir.
yeah, hydrocarbons. So if we take these hydrocarbons, we all know that we studied hydrocarbons means only it is made up of two elements. What is the two elements, everyone? What is the only two elements present, all of you? So one is carbon and another one is what?
Hydrogen.
Hydrogen. So now these hydrocarbons we classified into two different types. So that is what we used to say. One is saturated hydrocarbons and another one is what? Unsaturated.
Unsaturated.
Yeah, unsaturated hydrocarbon. Now, if I remove hydrogen from them, like unsaturated means we will take double bond and unsaturated means triple bond. Saturated means what, everybody? Saturated means all are what? All are single bond. All are single bond, we used to say saturated. At least one double bond. Unsaturated, at least one triple bond, we used to say unsaturated. So both are together unsaturated only. Now, these organic compounds, if I remove one hydrogen and if I replace with the other elements like oxygen or chlorine, bromine, iodine, so that is what we used to call it as a heteroatoms. So if you add that, if I replace the hydrogen and if I add another elements, so that is what we used to call it as a functional groups. So we are several functional groups we attain. That is what, if I replace one hydrogen and if I add OH, I will get alcohols. If I add, so different functional groups we studied. Do you remember, everybody? So alcohols, first we will get it what? Haloalkanes. Alkanes we got it. So means either chlorine or bromine or fluorine or iodine, we are going to add it. So if we add them, we'll get haloalkanes by replacing one hydrogen. So now, they are also organic compounds. We have aldehydes, we have a ketones, we have a carboxylic group. So like that, several functional groups we have studied. So these all are called it as a derivatives of hydrocarbons. Means from the, that is why they used to call derivatives. Means from the hydrocarbons, we are just modifying something and we are attaining the new properties, new compounds. So that is what we used to call them as derivatives of hydrocarbons. So whatever we attain, haloalkenes, so carboxylic acid, ketones, aldehydes, alcohols, all these all are derivatives only. I hope you all are learned the functional groups of everything. Am I right, everybody? Functional groups are clear or not? All of you. So now, if you take this, we are having a two different kind of hydrocarbons. So one is whatever it is, in this also, aldehydes also, ketones also, carboxylic, or whatever it is. So generally, if you take hydrocarbons, these all are attaining by just modifying one or two, like heteroatoms. New atoms are introducing in the hydrocarbons. So we are obtaining the different functional groups. So now chemical properties of carbon compounds, we'll talk about again the hydrocarbons only. So if I talk about hydrocarbons, so hydrocarbons are again two types. What is that, everybody? Hydrocarbons are considered as a two types. What is that, all of you? One is saturated hydrocarbons
Saturated.
and another one is what?
Unsaturated
Unsaturated
hydrocarbons.
hydrocarbon. So now, keep it in mind, if you are not understand also I'm saying, generally saturated hydrocarbons shows substitution reaction. So what is the substitution? We will discuss it. So saturation hydrocarbons will show substitution reaction. and unsaturated hydrocarbon shows addition reaction. So there is a two types of chemical reactions which we will discuss it. Okay. So saturated hydrocarbons will show substitution reaction. We will discuss what is the substitution reaction. And unsaturated hydrocarbons shows what, everybody? Addition reaction. Now, the most common chemical property, both, okay, both common chemical property is combustion. So combustion in air. So we all knows that combustion in air means what, everybody? Burning in air. Do you understand, all of you? So burning in air is the most common property for both saturated and as well as what? Unsaturated hydrocarbons. So by burning test or by burning in the air or combustion in the air, we can identify either it is a saturated hydrocarbon or unsaturated hydrocarbon. I hope you all understand what I am trying to say, everybody. Are you clear? So basically, saturated hydrocarbon shows what reaction? Substitution reaction. And unsaturated hydrocarbon shows what reaction? Everybody? Addition reaction. But both substances, either it is a saturated or unsaturated or doesn't matter. They will show the common property. What is the common property, everybody? Combustion in air. Means when we burn in air, we can identify either it is a saturated or it is a unsaturated. I hope you all understanding what I am trying to say. So that is the common property of both all the all the hydrocarbons, either it is a saturated or unsaturated. So you write a point. What is the point you have to remember, all of you? The most common chemical property of all the hydrocarbons, either it is a saturated or unsaturated, the common property is combustion in air. What is that, everyone? Combustion in air. That is what you have to remember. Now, let us start with the combustion, first property. So, combustion is the common reaction, or it is only for saturated? Everybody. It is for both saturated and unsaturated hydrocarbons. Okay. So, what do you mean by combustion? We already know from the first chapter we are studying. So burning, actually. So burning in air. So burning in air means the even class 10th chemistry starts with the burning reaction only. So burning in air means we used to call something. Nimish, can you tell me? What is the first example we studied in chemistry, class 10th? Burning of magnesium. Burning of magnesium is an example of what, Nimish? Burning of a magnesium is an example of some reaction. Can you tell me? Burning of magnesium. Magnesium reacting with oxygen, from that it will form MgO, 2MgO plus 2Mg. It is an example of under the what? It is a type of reaction. What kind of reaction it is? Anyone? Hurry.
Combination
It is a
reaction.
combination reaction. Now it is not having importance. There is another type of reaction. Addition of oxygen. What we used to call? Yes, oxidation reaction. Do you understanding? So it is a oxidation reaction. Do you all remember or not? So that is what is here exactly. So combustion reaction means actually a complete, now onwards every line is important. So complete oxidation reaction. Complete oxidation of any substance. That is the meaning of combustion. Combustion means complete oxidation of any substance. So all the hydrocarbons, not one, either it is a saturated or unsaturated, doesn't matter. So all the hydrocarbons, now onwards everything is extremely important. Please note it. All the hydrocarbons combine with oxygen And they will give the common products. So they will produce carbon dioxide and water. Do you understand what I'm saying? So if you burn a saturated hydrocarbon, alkanes, if you burn unsaturated hydrocarbons, alkenes and alkynes, doesn't matter. Everything will give us same carbon dioxide and water. That is what you have to remember. Are you understand what I'm saying? All of you? Yes, please. Everybody clear? So now you can take anything. You can test it and you can do it. So let us check it, all of you. It's not only, remember all of you, not only the hydrocarbons, the derivatives of hydrocarbons also gives us carbon dioxide and water only. So let us see that now. So during this reaction, large amount of heat is released so that it is exothermic or endothermic. Large amount of heat is releasing. Every combustion reaction is a what reaction? Large amount of heat is released. So it is exothermic or endothermic, guys?
Exothermic.
Yes. So large amount of heat is released, produced. So it is a exothermic reaction. So please note it, all of you. Exothermic reaction. So majority of the fuels are hydrocarbons only. The fuels what we are using in our surroundings. Fuels. What is the use of fuel? Anybody? Actually, what is fuel? The energy is stored inside. So fuel means what? When it is burned, what will happen? The energy is released. Energy is released. So that is what we used to call it as energy is released mainly in the form of heat. So that is what we used to call it as a fuel. So majority of the fuels what we are using in our daily life now, all are hydrocarbons only. Most of the fuels are hydrocarbons, which what they will produce, guys, when you heat them or when they will go combustion or complete oxidation, both are same. Don't get confused. So either combustion or complete oxidation. Combustion itself is a complete oxidation. So they will produce the energy in the form of what? Everybody. Energy is released in the form of what energy? All of you. Heat energy. Okay. So now, for example, let me take all of you. So basically natural gas if I have taken. So what is the major constituent of natural gas? I already taught you people. Natural gas mainly contains major constituent of natural gas. 8th class, 9th class itself is studied. Natural gas major constituent. LPG gas, liquefied petroleum gas major constituent. Natural gas major constituent is methane. Please note it. And LPG gas major constituent is butane. What is the butane formula? C4? Yes, please. HC4H10. Major constituent. Note it. Major constituent of natural gas, methane. So, when it burns in oxygen, and if you give sufficient amount of, you can see that. So, methane will burns in the oxygen. What will happen, everybody? What is the expected products? It's a fuel, guys. So every fuel will undergoes combustion reaction. It will produce the common products. What is the common products they will produce? All of you?
Carbon dioxide, water.
Carbon dioxide and water, and large amount of heat is released. That is what is our energy. So it they'll produces carbon dioxide plus water plus heat energy. That is why it is exothermic reaction. So now balance the equation fastly. Make it quick. CH4, here H2, 2H2 is there. So 2 oxygens here O2, 2O2 plus 2, 4, 4O2 over. Am I right? 4O2, 2O2, sorry, 2O2. So 2O2, 2 plus 2, 4. So CH4 plus 2O2 gives you CO2 plus 2H2O plus heat. So this is what it is. So along with the heat, along with the carbon dioxide and water vapor, they will release a sufficient amount of heat. So that is what if you have taken. So for example, if it is incomplete, suppose this is a sufficient oxygen, that is very, very important. So sufficient oxygen is produced, sufficient supply of oxygen. This is what is happening. For example, incomplete combustion. So what will happen, everybody? Instead of carbon dioxide, some other poisonous gas will release. What is that? All of you. If it is incomplete combustion, all of you. Yes, please. Incomplete combustion means what happens? Instead of carbon dioxide, I already told you, dangerous gas will release. What is that gas? Carbon monoxide will release. So by that time, heat energy kadayadu. Energy means heat energy is very like what we can say is complete. This reaction is very, very common in automobiles, basically. So where complete oxidation does not take place. So they will cause us indirect pollution. So very, very highly dangerous reaction. Most of the automobiles, this is the reaction which is carried out. So improper combustion. So incomplete combustion takes place basically in automobiles because of no proper service or no proper maintenance of the vehicles and all. Or if it is like a good quality of fuel is not using, or if there is any problem in the vehicle. So that is what we can say basically old automobiles. So old automobiles which is like expired more than 15 years, 20 years if you are using the same vehicle. So very, very dangerous. Even traveling behind the old buses and all is also dangerous because their incomplete combustion will take place and will produce a most dangerous gas. What is that gas, everybody? Carbon monoxide. Even similarly, incomplete combustion of coal also will take place. So incomplete combustion of coal also. Coal means what is that? Coal measure, what is the major constituent of coal? Everybody. Carbon. Understand? So here also if sufficient of oxygen supply illa, so that is also will produce us. That is also will produce incomplete combustion. Incomplete combustion means that is what I said. If there is no proper ventilation, no exchange of oxygen and like that's what gases, then like a closed room, burning something in a closed room. So then definitely you can see it will releases the carbon monoxide. Incomplete combustion. So please learn that. Understand all of you? Clear, everybody? So now, if you have taken next, so for example, saturated derivatives of hydrocarbons, saturated hydrocarbons. So can you tell me what is the derivatives of saturated hydrocarbons? Derivatives of alkanes only. All the functional groups what you studied, everything is derivatives of alkanes, alkenes. Everything alkanes only. Am I right? Please respond, guys. Whatever the derivatives we studied, like alcohols, ketones, carboxylic acid, everything is from alkanes. Am I right or wrong? Everyone?
Yes, sir.
Yes or no?
Yes, sir.
So that is what. So now for example, so let me take the derivatives of alkanes, alcohols. So what is the alcohols? First one, first member of alcohols. Anybody? Alcohols. General formula tell me. CnH2n plus 1 and OH. So you can check it. What is that? What is the functional group of alcohol? OL, OH only. Am I right? So what is the first one? C1, H21 plus 1, OH. So which is equals to C1, H2 into 1, 2 plus 1, 3. So C1, CH3, OH. Am I right, Amma? Is it right or wrong? CH3OH is the first one. Methyl alcohol, or we can say methanol. So how many of you know spirit lamps? Spirit lamps. You can see that. Olden days and all, still, of course, we will use till today. Alcohol lamps or spirit lamp will say. Am I right? If you go to the ancient time or just 20 years before, even my childhood, I remember, every home there will be a kerosene lamp. Am I right, Harish? Girls, anybody have experienced the kerosene lamp? All of you? Kerosene lamp. Kerosene ra, if there is no current, they will put kerosene inside the bottle and like a deepam. it will be. So one thread like it will be coming, inside kerosene will be there, and it will be keep on giving the light. Do you remember everybody? Spirit lamps we used to say.
Yes,
So
sir.
basically, yeah, kerosene lamp. Even government used to supply this kerosene long back. Now, almost 10 years before they stopped it. Why means major pollution. Kerosene is unsaturated hydrocarbon causing too much of smoke. So, but if you see the spirit lamp, where we will use alcohol is like burning. Even in our school, you can see lab, chemistry lab. If you go, you can next time you can check it. There will be a spirit lamp where we people will use alcohol. So basically, so that alcohol is a what? Saturated or unsaturated one? Yes, please. Saturated or unsaturated? If I take methanol and ethanol, these all are saturated one. Do you understand? So derivatives of saturated hydrocarbons. So if I take this methanol, ethanol and all, basically they are all are saturated. So if they are saturated means you can see the saturated hydrocarbons having high percentage of hydrogen. The percentage of hydrogen is high. Note it. Saturated hydrocarbons, the percentage of hydrogen is very high. Not regarding this I am saying. So these are the derivatives of hydrocarbons, such alkanes. They are the derivatives of alkanes. So saturated hydrocarbons, percentage of hydrogen is high. Noted. So they burn with a smokeless flame. That is the most important word. Note it, everybody. Smokeless blue flame. So from this, you have to learn one point. Saturated hydrocarbons burns with a what flame? Everybody? Saturated hydrocarbons burns with a what flame? Yes. Saturated hydrocarbons burns with a what flame? All of you? Smokeless blue flame. Smokeless blue flame. That is why the fuels which have high percentage of hydrogen, are considered as better fuels, are considered as better fuels. Note it, everybody. Considered as better fuels. All of you do understand what I'm saying? All of you clear? So which is the better fuel? Saturated hydrocarbons or unsaturated hydrocarbons? Which you feel more comfortable to use? Which will produce less smoke? Saturated or unsaturated? Unsaturated we not discussed till now, but of course we will discuss. Understanding? So saturated hydrocarbons, whose percentage is more? Carbon percentage or hydrogen percentage? Everybody?
Hydrogen.
Hydrogen percentage. Note it, everyone. Very important point. In saturated hydrocarbons, hydrogen percentage is high. So that is why they burn with a smokeless blue flame. So that is why you take it. In our gas cylinder, we are having saturated hydrocarbon or unsaturated hydrocarbon. Gas cylinders. Anybody? Gas cylinders.
Saturated.
Saturated hydrocarbon. That is why your mother can cook faster in gas compared to by burning with the wood. Because wood will burn with the what flame? What is the flame you can get wood by burning the wood? What is the flame you can observe? Basically,
Yellow flame.
yellow flame. So that is why cooking in that by burning the wood, that is what we can say our old methods. It will take time consumption process. But now gases very fastly you are cooking. Why? Because it is a high heat energy will release. So that's what we can say. If it is smokeless and blue flame, we'll consider it is a better fuel. Who is having more hydrogens, they are actually the better fuel. Suppose if you take methane, so CH-4, next ethane, C2H6, butane, propane, C3H8, butane, C4H10, Pakranga. A percentage of hydrogens hydrogens are more than carbon. Am I right or wrong? Do you all understanding what I'm trying to say, everybody? So hydrogen percentage is high. Hydrogen percentage is very, very high. So these fuels are considered as better fuels. They will burn with a blue flame. And even the derivatives of them, like if you take a spirit lamp, it is also derivatives of alkanes. So let me take methane, CH3OH. So if you burn in the presence of oxygen, so that is also they will produce as what? Carbon dioxide plus water plus heat energy. So here balance the equation fastly, everybody. Harish, balancing equation. So CH3OH 3 plus 1 4, but here only 2. So what will happen? 4 hydrogens we have to get, and carbon dioxide also. Oxygen, check it. Oxygen's 2 plus here, here 2 only. 2 plus 1 3, here 2 plus 1 3. So balancing I want it, make it quick. How to balance this equation? Fastly. Everybody? Yes, please. I want balance to this equation. Something is not balanced. If you check it, you can make it. So what is not balanced? Only hydrogens. So by balancing hydrogens, we can balance everything. Yes? Yes, Vignesh. Firewood stove is the cooking use in wood only. So balancing equation, tell me nobody is there. Balancing equation, methanol. Mitakshri, ethanol plus oxygen reacting, it will produce carbon dioxide plus water. So what is the balanced equation? This much time. By balancing hydrogen, you try to balance it, guys. Hydrogens here henge 3 plus 1 4, but here only 2 is there. Next check it, everybody. If I try to check it, 2 steps it will come. If I try to balance it, 2H2O. So hydrogens are balanced, but oxygen become what? Imbalance. Now oxygens how many? 2 and 2 4, but here only what? 3 only. So I will try to balance the oxygen. So 2CH3OH, oxygens balance mudinjicha. Now hydrogens become imbalance. Again, pakranga. Hydrogen become not carbons, we can take it. 2 carbons, here only 1 carbon. So I will balance the 2 carbons. Now oxygen alone is imbalance. 2 oxygens, 2 plus 2, 4. But here pakranga, how many? 2 twos are 4, 4 plus 2, 6. But here only 4. So here I will put 2. 2 or 3. Check it, everyone. I want to get it. Sorry, once again, I'll teach. No problem. So first I'll try to balance hydrogen. So hydrogens, how many are there? All of you observe. Balance equation. It is not easy, little one. So hydrogens first, how many? First carbons. Carbons balance, no problem. Next, hydrogens verify. Here 3 plus 1, 4, but here only 2. Next, oxygens. 2 plus 1, 3, and here also 2 plus 1, 3. Okay. First, hydrogens are imbalanced. So which side I have to balance? Here 4 hydrogens, here 2 hydrogens. So I will put here 2. So 2H2O plus CO2 gives you O2 plus CH3OH. Now, I try to balance the hydrogen. Now something become imbalance. Oxygen become imbalance. How? You can notice it. Hydrogens, 2 twos are 4, 4 over. Carbons, 1, 1 over. Oxygen, check it. Here 1 plus 2, 3. But here 2 plus 2, 4. So that is why to make it balance it. So what I am doing? I am multiplying this CH3OH whole thing with the 2. So that oxygens become balanced. 2 plus 2, 4. 2 plus 2, 4. But now carbon become imbalance. So what is the carbon now become imbalance, everybody? Here 2 carbons are there, but here only 1 carbon. So again I will multiply with the 2 here. So now carbon and hydrogen verified. 2 carbons over hydrogens. 2 here, 2 threes are correct. 6, 6 plus 1, 7. But here 7 not. Correct only. So 6 plus 1, 7. Now here hydrogens you verified. 7, how many hydrogens? Sorry, Amma. Yeah, 3 hydrogens. 3 and here total hydrogens how many now? CH3, correct? 2 CH3. 3 plus 3 to 6 plus 1, 7. But here only 4 hydrogens are coming.
Sir, 8 hydrogen.
Where is the hydrogens?
For CH3 OH. For
Ah,
H also 2
yes,
hydrogens.
yes. Two threes are 6 plus 2, yes, 8 hydrogens. But here only 4 hydrogens only we have. So now to balance it again, so what I will do? I will change the hydrogen instead of 2, I will make it into what? Everybody. I'll make it into 4. So now you check it, everybody. So what will happen? Hydrogens become 8. Here also hydrogens become 8. Next, oxygens. Here how many oxygens? 2, and here 2 plus 2, 4. But here 4 twos are 8. 8 plus 4, 12 oxygens are there. So to make it 12, but here 4 only. So what I have to do it, everybody? 2, 12 or 8 oxygens. Check it, Ra. Sorry, Ra. Oxygens. 2 twos are 4 plus 4 oxygens. Totally how many oxygens are there? 8 oxygens are there. But here how many oxygens? 2 plus 2, 4